Our ecological focus involves the attraction of a mate and how it is fundamentally important for one's fitness and the survival of a species. As an example, male crickets have developed acoustic signals to attract their female mates. Simmons and his research team in 2013 have suggested that these crickets are conveying information about their physical attributes through their signals. Supporters of this idea agree that different signaling sounds allow males to portray their fitness to females that are seeking a high-quality mate. This brings to question what possible frequency differences allow males to be more successful than their competition at producing these acoustic sounds. While Simmons and his research team also explained that the crickets display two songs during courtship, which is either an acoustic signal or a courtship song, leading to the proposal that there is a difference in cricket chirps in general, potentially leading to favored frequencies.
For courtships of crickets, the male repeats a chirping sound to attract females. With this being said, our hypothesis is that different frequencies of the chirping affect females' courtship behavior, such as the amount they move. There has been some research done on this topic. One study in 2008 done by Muradian and Walker proposed that difference in frequency may convey a message to the females as to how large or small the male cricket is based on the size of their harps. This supports the view that higher frequency is preferable for females. In light of this research, we predict that if we test the frequencies of male cricket chirp, then the higher frequency will attract the most females.
We are using a fish tank because it is clear and easy to see the movement of the crickets in. There is added mulch, dirt, and sticks from outside in order to mock the natural environment to get the most accurate chirps from the crickets. The tank is divided into two sections, one section being 20 centimeters long and the other being 10 centimeters long. We are using an aquarium divider to keep the sides separate but visible to the other side. The tank does also include damp cotton balls for water and cricket food. The top of the tank is mesh and see-through so we can visibly see the movement of the crickets. We are also recording all trials from above, so we will have an aerial view of the tank as well. There is also a ruler on the long side of the tank to keep track of the distance traveled by the crickets.
The main focus of the research was following female movement to males chirping. So the female movement was recorded from horizontal movement, meaning that we completely disregarded the side to side. They would do from one end of the cage to the divider separating the males. Movement towards the male would be considered positive movement, while heading towards the back of the tank was considered negative. Also, movement counted as crawling and jumping, just as long as there was some movement in a particular direction. In order to collect the data, a male was placed in the 10 centimeter long section, while the 20 centimeter long section contained the 3 female crickets. They were left alone in a quiet room ranging from 40 minutes to an hour and 15. The reason they would be left for that long is to provide them a built-in acclimation period, which typically took about 12 to 15 minutes for the crickets to acclimate before any sounds were heard. The start of the data collection would begin after the first chirp was heard from the male. On the graph, we recorded 23 chirps from the males and the average movements of the females after those chirps. The main unlook of the graph shows that with higher frequencies, there are more movement made by the males. The graph is scattered due to the movements being an average, which can be kind of tricky because not all the movements of the females were same. Even though the points are scattered, you can still see an increasing with the positive linear regression. That being said, the graph supports the hypothesis by showing a positive incline due to the linear regression line. The positive incline supports that the higher the frequency, the more the females will move for the male, bringing to light that female crickets prefer those higher frequencies as opposed to the lower. The idea has the potential of possibly alluding to other animals having similar outcomes.
In 2001, Witt and her research team explained that not only do crickets use vocal sounds to attract a mate, but birds, frogs, and many other insects do as well. It would be interesting to see how the frequencies compare between different species, and could high frequencies be favored in these other organisms as well.